Hey everybody, we have a problem that I would prefer to call direct translation. There's no special results really required to solve this problem. Um, I forgot to write down A and B are going to be integers here also. Okay, members of Z. And again, we're looking for the value of K. K appears here also, and we're looking for the largest value of K such that both of these objects are square integers. So we directly translate it. We literally write down, we just force it to be the square of two integers. Now, if you carry on here, the rest of it's fairly routine. When you subtract this from this, the k's of course cancel, and you get 399 minus 184, which is 215. Now we look at the difference of two squares results, because we can look at the prime factorization of this number, and it only has two prime factors, namely 5 and 43. Now notice we could look at the negative product. We could look at minus 5 times minus 43, but we're looking for the largest, and we'll see that the negative values wouldn't. They end up doing the same thing basically, but they wouldn't be the largest value. Okay. Now, so let's carry on. Now, of course, case 1, any number is equal to 1 times itself, so we do have to consider that case. Okay, 1 times 215 doesn't appear in the prime factorization because neither one of those are prime numbers, but 1 and 215 are divisors of 215, of course. All right, now, when you carry on like this happens because think of adding these two. If you add these two expressions to each other, b minus a plus b plus a, the a's cancel, right? And so that's where this 2b would come from. Again, note that if you just add these two equations, you can add equals to equals, right? Well, when you add b minus a to b plus a, the a's cancel, but you get 2b, and of course you have to add 1 in 215. So that leads to this truth that b is equal to 108. Okay, now from there we quickly get that a would have to be 107, right? For this part total, this is the easiest place to do the calculation. And of course it would happen here also. It's just easier to do the calculation. Right here, if b is 108, a has to equal to 107 in order for this equality to hold. So we see that 108 squared minus 107 squared is equal to 215 without even knowing what 108 squared is. That's kind of nice. The algebra scales things down for you where you know that 108 squared minus 107 squared is 215. A lot of people probably reach for their calculators, but it's guaranteed to be true just based on these factoring results. Okay? And so with 108 as the choice, we would get k equals to this. And so we would get k equals to this value right here. Now notice just for emphasis, I wrote down two restatements of these two objects. You don't necessarily have to do that, but it's both of them have to yield, arithmetically have to yield the same result. In this case, it's the number 11,265. Okay, so we've gone through case 1. Now we have to go through the case where we have 5 and 43. Remember, 5 and 43 are the only prime factors of 215. Now in the very similar fashion, we get 24 right here. Okay, and then you would get 19 if you substituted right back in here. Okay, but you can see there's no way 24 is going to give us as large a number just from the structure of the substitutions here, or just the way this is stated. 24 is a much smaller number, which will result in a much smaller k, right? So in other words, the k here, whatever it is, and you don't have to go, you can just see it, the k that you would get here would be less than 11 to 65, and that's okay. You can look up and see it and say that this is okay, I think, in competitions to say something like this, because you've demonstrated you're doing a certain type of work here. The same kind of work here would lead to a k that's less than 11,265. So this is the answer. K equals to 11,265. And if I did the arithmetic wrong, that's just equal to both of these expressions. All right, so answer is, if I can remember it, k is equal to 11,265. There we go, folks. That's the answer. And again, I kind of like this because once you're convinced this is the prime factorization, if there were more prime factors here to consider, we would have more cases to consider here. Okay, so this one worked out rather nicely just because 215 is fairly close to being prime itself. But if you had a much more involved with many more prime factors raised to exponents, you would have a lot of cases. In fact, that's a combinatorics result to say to show what that would be as a function of the prime factorization. But that's another video. All right, thank you for viewing.